We were basically looking at kinematics, and I was trying to explain that when we speak about kinematics now in differentiation, we are speaking about, again, a topic that you have seen, which is linear motion. And in linear motion, you came across displacement and distance. And we say the main difference between displacement and distance is the fact that displacement has got a direction, but distance doesn't have a direction. For example, if you walk from a certain point 100 meters away, you go 100 meters away, and then you come back to the same point, your displacement is zero because you have gone for 100 meters and then you've come back for 100 meters. So that means in total, the total displacement is zero, 100 minus 100. But for the distance, you will have gone 100 meters and come back 100 meters. So that means that the total distance covered there is 200 meters. And then we also spoke about the velocity and the speed. Again, velocity here is our vector quantity, whereas speed is going to be our scalar quantity. And we expect that when we solve solutions and we solve questions and we find out that the velocity, for example, is negative, that is an acceptable answer. If we find that the speed or the distance is negative, that answer is not acceptable because, again, distance and speed do not have direction. The negative indicates a direction. And then we say the last quantity that you are going to be able to experience in kinematics is now acceleration. And I was trying to explain here now how do we relate this linear motion with now differentiation. In that case, we remembered the graphs of linear motion. And for example, when you have got this graph, a graph of displacement against time. When you have got a graph of displacement against time, we normally say that the gradient here is going to be equivalent to the velocity. And the gradient is given by the change in displacement all over the change in time, whereby we said this can also be related to as we differentiate the displacement with respect to time, so that now that one gives us the velocity. So anytime we differentiate the displacement with respect to time, we always get the velocity. And then we looked at the other graph, which was a graph of velocity against time. In the graph of velocity against time, when we take the change in velocity all over the change in time, which is that always gives us the acceleration. It always gives us the acceleration. And so now in calculus, in differentiation, when you differentiate the velocity with respect to time, then it always gives us now the acceleration. And again, acceleration is a vector quantity also. So we can have positive acceleration or we can have negative acceleration, which in one word, negative acceleration, what do we call it? A volunteer? What do we call negative acceleration, Howie? Exactly. We call negative acceleration a deceleration. Another word that can be used, there is another word that can be used to indicate the same. Amos? Amos? Very good. It can also be called retardation. We can say it is a deceleration or it is a retardation. And so, after we saw that, we went ahead and did this example here.